Hello everyone, welcome back to Priyan Classes. I am Prabhat Kumar once again with you. As I have promised in my previous video for derivatives in respect of standard 12th. The video was cut short due to paucity of time, and now I am continuing with the next part of the chapter. Before I move to the next part of the chapter, I would like to explain you the certain things because I wanted to give you how to differentiate the inverse functions, especially the inverse trigonometric functions which you have studied in standard 12 only. Okay, so before I go, I would like to give you one more thing, one more type of function, that is called implicit function. Now, I don't know whether you have understood this or not. This is implicit function. See, what happens if you are able to express y separately as a function of x. I repeat, if you are able to express y as a function of x, that means taking only y on one side and all other terms of x to the other side, then it is called an explicit function. Suppose that you are given y equal to 3x square plus 5x plus 2. In this case, you have expressed y separately as a term as the function of x. So this type of function is called explicit function. Okay, but there may be some condition where y will not be easily expressed. Suppose that I am giving you an equation that xy plus x plus 2y square plus 3x is equal to 0. Now you see, this is not easily possible to express y as a function of x. Okay, so this type of function is called implicit function. Now, how to differentiate such functions? I will take this one only. Okay, and in this case, I will try to find out what will be dy by dx in such conditions. Okay, so basically when I say differentiate with respect to x, that means we have to differentiate y with respect to x, or I have to find out the rate of change of y with respect to the change in x. So that is called dy by dx. I am taking an example. Suppose that I am given 3xy plus 2y square plus 5x is equal to 0. Okay. Now, when I am differentiating with respect to x, the first function, the first part, as you know, that you have got three terms, and all three terms will be differentiated being sum of three functions. This function is actually a sum of three functions. So all these three will be differentiated like that. So this will be, now this one separately is a product of two functions. So this will be 3. First I will differentiate x, that will become 1 multiplied by y, plus x will be taken and this will be differentiated, and differentiation of y will be what? Just dy by dx. Okay. Similarly, from the second term, again this 2 is constant, so no matter what happens, for y it will be 2y and then dy by dx, and plus 5, this will be equal to 0 because differentiation of x is 1. So now this becomes 3y plus 3x dy by dx plus 4y dy by dx plus 5 is equal to 0. Now this 3y and 5 will be taken to the other side, so it will become, and from these two I will take dy by dx as common, minus 3y minus 5, or dy by dx will be minus 3x plus 5 divided by 3x plus 4y. This will be the differentiation. Okay, so this is how we can differentiate an implicit function. Now using this method, now I am going to differentiate the inverse trigonometric functions, and then I will do with exponential functions and logarithmic functions, and then there is one parametric function also. Now I will explain what those things mean as I proceed in my class. Okay, so before that I would like to differentiate the inverse trigonometric functions. Differentiation of inverse trigonometric functions. Okay. Suppose that I am given y equal to sine inverse of x. Okay. Though it is explained as a as an explicit function, but I don't know how to differentiate sine inverse x. So instead of taking it like that, I will convert it to an implicit function, or for this I can write as sine y equal to x. Okay, sine y equal to x, so this will take it as equation 1, and now differentiate with respect to x. What it will become? Sine y, differentiation of sine y is what? Cos y multiplied by dy by dx equal to 1. Okay? Or I can say that dy by dx is equal to 1 by cos y. Okay? But I should express it as far as possible in terms of x only. Okay, so what I will do it, I have to convert it to the form of x. How? You know that sine square x plus cos square x, that you have studied in your previous class, not in my previous video. In your previous class you have studied that this is equal to 1. If this is 1, that means cos square x will be equal to 1 minus sine square x, or cos x will be written as square root of 1 minus sine square x. Okay, so using this I can write it there 1 by square root of 1 minus sine square x, or it can be written as sine x square also. And what is sine y? Sorry, it is y, so it will be written y. Okay, 1 minus sine square y. And what is sine y? Sine y is equal to x. So my dy by dx is equal to 1 by square root of 1 minus x square. But there is again a condition. Condition is what? First thing, if it is sine y is x, then x will always be lying between 1 and minus 1, or I can say minus 1 to 1. But if value of x is minus 1 or 1, whatever it is, it will become 0, and once it becomes 0, my whole value becomes non-defined. Okay, so for this the domain of x will be, where it is differentiable, is that x will be lying between x will be in the open interval 1 and 1. It will take any value between -1 and 1, but the values should not be equal to -1 or 1. And similarly, the range of the function should be what? If this is so, then range is pi to minus pi, or I can say pi 0 to pi, but it should not be 0, it should not be pi, otherwise it will become a different value. Okay, so now let's proceed further with cos inverse x. If it is given y equal to cos inverse of x, it is, I don't want to go in detail for this. It is once again similar to that of sin inverse x. So instead of using cos inverse x, it will be, now I will take y equal to tan inverse of x. Okay, it will be tan inverse of x. So again, as usual, I will take it as tan x or tan y will be equal to x. Now I will differentiate, and this will become sec square y dy by dx equal to 1, or I can say dy by dx is equal to 1 by sec square y, and just remember sec square y was equal to, or I can say sec square y, I should write it as sec square theta minus tan square theta was equal to 1. Okay, so this can be written as, I can say sec square theta is equal to 1 plus tan square theta. So this will be written as 1 by 1 plus tan square y, and tan y is what? X. So here dy by dx is equal to 1 by 1 plus x square. Okay, so this way you can find out what will be the, I am leaving as an exercise or as practice the other three, like sec inverse, cos inverse x, sec inverse x and cosec inverse x. I am leaving, I am not including in this video, just because so that you should practice on your own and try to derive the formula for this. Okay, now let's proceed further. The next is exponential function. Exponential function. What do you mean by exponential function? Exponential function is basically, it is e raised to the power x. So it will be represented as y equal to e raised to the power x, the first basic thing. Where what is e? E is called the Napier's constant. E is called the Napier's constant. Now for finding the differential coefficient or differentiating this, I shall use the expansion of e raised to the power x. So if this is so, I will write y expand. I will expand it, and this expansion is what? 1 plus x by factorial 1 plus x square by factorial 2 plus x cube by factorial 3 up to infinity. Just remember from the sequences and series chapter that you have studied in your previous class. Okay, so this is your expansion. Now if I differentiate it, what will happen? Left hand side will be just dy by dx, and right hand side will be what? 0 plus 1 divided by factorial 1 plus 2x divided by factorial 2 plus 3x square divided by factorial 3 plus and so on up to infinity. Okay, just I have differentiated all because the denominator was the constant and numerator was differentiated like that. Okay, now this is 0, I will leave it, and then this becomes 1 plus, now you see 2 by factorial 2. Factorial 2 is what? Product of first two natural numbers. So if 2 is taken out, that is 1 multiplied by 2, so if 2 is taken out, it becomes, or it will become factorial 1. So it will become x by factorial 1, because you know what is happening. N factorial n is what? N multiplied by factorial n minus 1. This n I am taking out, just from this 2 I am taking out, it will become factorial 2, and this 2 will be cancelled out with this 2. Similarly, from the next term, I will take out 3, so it will become factorial 2. The 3 taken out will be cancelled out with this 3, and it will become x square. And similar terms will keep on coming. Okay. Now see the fun. What this is the same thing. That is equal to y. Okay. This expansion is same as that of y. So I can write that dy by dx is equal to y, or I can write d by dx of e raised to the power x is equal to e raised to the power x. Okay, this is your differentiation for a logarithmic function. Okay, now sorry, this is for exponential function. Now I will proceed for logarithmic function. Once again, it is, once you have understood this, logarithmic function is a very easy using this function and using the method for differentiating implicit functions. It will become very easy and just 2 or 3 step task. See, suppose that I am given y equal to log x. One thing you should keep in mind, that when we are dealing in calculus, the logarithmic function means it is to base e. In your previous classes where you have studied about logs and log tables and calculations using the log tables, you have used the base as 10. But in calculus, when you are doing differentiation or integration, whatever it is, the base should be e. If it is not e, if any other base is given, just convert it to base e by using the formula that you have studied in your previous classes. Okay, so now if this is so, what does this mean? This means that e raised to the power y is equal to x. Okay, e raised to the power y will be equal to x. Now I will differentiate. Remember, I have to find out dy by dx. I will differentiate this, and what this will become? It will become, because this is differentiation, it will be e raised to the power y multiplied by dy by dx, and right hand side will be equal to 1, and so dy by dx is equal to what? 1 by e raised to the power y, or dy by dx is equal to 1 by, what is e raised to the power y? That is equal to x. So I can say d by dx of log x to base e is equal to 1 by x. Very easy. Okay, so this is one of the easiest portion that you have done. Now I will proceed to parametric functions. In parametric functions, y is not expressed as a function directly as a function of x. Not even x is expressed directly as a function of y. Okay. What happens? Both x and y are expressed as functions of a third parameter. Okay. What? How? Suppose that y is given as a cos theta and x is given as b sin theta. So here you see y is expressed as a function of theta. A is a constant. Similarly, x is expressed as a function of theta, not as a function of y. But in this case, I have to find out dy by dx. How? Now you see, I will just take the first equation, that is y equal to a cos theta. I will differentiate it with respect to theta, not with respect to x. Okay, I shall differentiate it with respect to theta, not with respect to x. So when I differentiate with respect to theta, what I will be getting? I will get dy by d theta. Correct? I will be getting dy by d theta, and that will be equal to a multiplied by minus sin theta, or I can say minus a sin theta. Okay, so this is what? Dy by d theta. Similarly, I will use the other side. X equal to what? B sin theta. Again, I will differentiate this with respect to theta. Okay, so if I am differentiating with respect to theta, that means it will become dx by d theta, and that will be equal to b cos theta. Okay, so I have got dy by theta, I have got dx by d theta, but what I have to find out this one. Okay, so now I need some space here. Now if I divide, take it as equation 1 and take it as equation 2. Okay, now divide equation 1 by equation 2. What I get is dy by d theta divided by dx by d theta, and that will be equal to minus a sin theta divided by b cos theta. Got it? Now I can rub it out completely. So this will become dy by d theta multiplied by d theta by dx, as we have been doing for the fractions, division of fractions. Just the denominator was taken to multiplication with the reciprocal. Okay, and this side it will become minus a by b sin theta over cos theta. Okay, and from there d theta will get cancelled because these are both are changing the value of theta, So this is what dy by dx is equal to minus a by b, and this is what sine theta. Now once again, this sine theta is what? Can you express it as this? Either you leave the answer to this, dy by dx will also be expressed in terms of the same, that is theta. Okay, so this is how to differentiate when x and y are given in terms of a third parameter. So these type of functions are called parametric functions. So I think this is all how to differentiate different kinds of functions. Okay, now there is just one more concept, that is mean value theorem. Okay, mean value theorem is what? That is just very small part of this chapter. Suppose that first I will recall what is Rules Theorem. How many of you must have been knowing about the Rules Theorem? Suppose that there is a function f defined in the closed interval a b. That means a and b are inclusive. I think you can understand this. Okay, and this is belonging to R, so it is true for all values. Then it says, now it is continuous also, it is differentiable also. In that cases, there is at least a value. What it is said there, the way it be continuous in closed interval a b, that is it has the value from a to b, and differentiable in open interval a b. Remember, we cannot take the endpoints, because in one case I will not be having the right hand derivative, in other case I will not be having the left hand derivative. So it will be in the open interval. Then such that there is another thing, such that fa is equal to fb, or I should write it like that. Fa is equal to fb. Okay, then there is a value between a and b, where then there exists a number c between a and b. In open interval, that means between a and b it will be greater than a and less than, it will be lying between a and b somewhere, where f dash of c is equal to, f dash of c means value of the first derivative of the function at this point. And what is the meaning of value of the derivative? That is the slope of the graph. So when I make a graph like this, if I am finding out the slope at this point, what does this mean? This means the slope is the change in the value of y divided by change in the value of x. Okay, and that is what? That is the angle made by the slope, or angle made by the tangent with the positive side of the x-axis. Okay, so if I say, so differential is what? The rate of change is what? That is actually slope. So if the slope is 0, that means angle made by the tangent with the positive side of the x-axis is equal to 0, or I can say that the tangent is parallel to the x-axis. So in that case, what will be the graph? See, first condition was that there are two values of A. One is A, one is B. The graph is moving like that. Suppose that it is moving, okay, and FA and FB are equal to 0. Suppose that this is FA, okay, it will go and it will come like that, and it will be having the same value, will be FB also, okay. So if these two values, obviously if the graph has to return to this value, graph is moving, if it has to return to this value, at least its slope, you see, it keeps on changing, and at the peak it is parallel to x-axis. Just watch this pen. As it goes on, at the peak it becomes parallel to x-axis, and once it is parallel to x-axis, that means this is the point where it is parallel to x-axis, and this is the point C. So you will be getting a point C where it will be parallel to x-axis, or which will be having the peak value. Okay, now an extension of this. Extension means the same thing. What extension is? The same thing. F is, that is called the mean value theorem. Okay. In this case, this condition is not applied. Rest all is there. It is continuous, it is differentiable, rest all is there. Only thing is that this condition is not given. Okay. Then there exists a number C in the open interval AB such that in this case f dash C, this will become FB minus FA divided by B minus A. Once you see the graph, you will understand what is the geometrical meaning of this. Okay, I am just taking this and I am rubbing out so that I can get the complete space for making the graph. This what I said, f dash C was equal to FB minus FA divided by B minus A. Remember, in this case, FA is may be equal, may not be equal. The condition is not given to you. Okay? See what will happen. This is your point A, and this is your point B. Okay? Obviously, this will be FA and this will be FB. Okay? Now, what will be slope of the line joining this point and this point? What will be the coordinates of this? B and FB. And what will be the coordinates of this? This will be A and FA. So, what should be the slope? The slope is what difference of y coordinates, that is fb minus fa divided by b minus a. But that is slope of these 2 points. Okay? But what it is saying? It is saying that there will be, see, obviously this slope is like this, and as I proceed to this point, it is saying that there will be at least one point where the tangent to the curve will be parallel to the line joining the 2 points. Okay? So there will be the line, there will be a point where the tangent will be parallel to this, or the slope of this tangent will be same as the slope of the line joining the points at A and B. Okay, so this is what this value will be, whatever is the point, that will be called C. Okay, and what is slope? Slope is differentiation. So I can say that f dash C will be equal to fb minus fa divided by b minus a. This is what? This is called the mean value theorem, or it is just expansion of the Rules theorem. Okay, so with this I will come to end of the chapter for derivatives. So I will once again request, just to go on this video, try to understand the concepts, because just understanding the concepts is much better way to understand the subject, and it is the most beneficial way, or it is the most easiest way to solve the problems. Okay, so with this I am wishing you good luck for this chapter, and I am coming to the end of this. But before I go, I once again request all of you, please subscribe the channel if you have not subscribed, and also don't forget to press the bell icon, because you will keep on getting new and new videos on all other chapters for your syllabus. Okay, so till then, goodbye.